All right. So my name is Ranga Settler, and I'm the co-director of the NSF Center for Identification Technology Research at UB. And it's my pleasure to welcome today's speaker, Dr. Sharat Chikkerur. Sharat is an alum of our lab, UB's Center for Unified Biometrics and Sensors, and he got his master's degree here at UB in 2005. Even as a master's student, he had numerous papers, patent applications. He earned kudos from the prestigious labs that he interned at while doing his master's. He then went on to get his PhD from MIT in 2010 from the now NSF Center for Brains, Minds, and Machines. It was then known as the Center for Biological and Computational Learning. He has previously worked at Google and at a data science startup called Nanigans in various research scientist roles. Sharat is currently the principal data science lead at Microsoft, and he leads a team of data scientists and engineers working on natural language processing and computer vision problems. He has multiple publications and patents in the area of biometrics, deep learning, computer vision, and NLP. He's always been enthusiastic and very happy to participate in STEM outreach activities. He has been a keynote speaker at CDSE Days in 2017, and he has graciously agreed to conduct this tutorial on Azure machine learning for this year's CDSE Days. So thank you again, Sharat, and a very warm welcome to you from Buffalo, literally since it's a 70-degree day here. So a little bit about the format of the, so let's just welcome Sharat. The format of the session, Sharat will be has a slideshow to start off with, and then some hands-on tutorial videos. And in the middle, there will be opportunities for the attendees to ask questions. There's two ways we can do this. One, typing questions in the chat panel, and we'll have volunteers here, including me, monitoring the chat and interjecting if needed to ask the questions. You can also raise your hand, and the volunteers will let you ask the question at appropriate junctures. But there are going to be breaks in the session where the speaker will ask for questions, and that would be a good place to have the Q&As. So once again, I'd like to remind everyone that this talk is being recorded and will be made available on the CDSE Days website later as well. With that, I'll let Sharat take over the controls and start. Please keep your videos muted, and we'll unmute you when questions need to be asked. Thanks.
Great. Thank you, Ranga, and everybody. It's always a pleasure to be back at CDSE. I think this is my third time around on CDSE Days. So great to be back. So I think what I want to cover today is mostly I'll give you a walkthrough of Azure Machine Learning. I think you might have had access to this GitHub page. I think I would prefer if you walk through the demo with me, do it as I do it, and you have, so in the preparations you have access. I've given instructions on how to get an Azure subscription, and so you should be able to do everything that I'm doing here today, and then follow along. And you have $200 credit, I think, as students. And I've been, this should take just a couple of dollars a day, even if you keep all of them running. So so that's more in terms of logistics. So I think, let me go back to the presentation. So so this is there. Let me just put it in the chat. I have a chat window open on another screen. So keep the questions coming, but I'll pause in between to answer some questions. There will be natural breaks during the 2 hours. Okay, let me switch back to the presentation. And before you guys joined, I had I put a link out for Microsoft New England. There we have a program called Microsoft AI Development Acceleration Program, a program that's targeted for new graduates from all degrees. So if that's something that you're interested in, please take a look and shoot me an email. I'll be happy to refer you. Okay. Right. So back to the agenda. So I think it's going to be sort of a three-part talk. So I'll sort of give you a brief introduction. That's this presentation for about 20 minutes or so, talking about generally cloud services and Azure machine learning services in general, all the flavors of Azure machine learning services, and then I'll switch to sort of hands-on demos. Again, this is something you can follow along on your laptops. And again, there will be natural breaks in between for you to catch up, or if you've already done it, ask Q&A. And this is also recorded, so you can follow along on your own pace as well. So I'll walk through 3 demos, each of which should take around 20 minutes or so. Again, going from a no-code experience to a low-code experience to fully custom code experience. So that's the progression. But again, while I talk about Azure machine learning here, I think the message is, again, this you will expect similar capabilities from other cloud providers, from other platform vendors. I think the goal here, if the take home, is to understand what is possible in the cloud, what are the advantages or acceleration that the cloud provides for your workflows. And also through Azure Machine Learning, again, this sort of sets your expectation of what you can expect a cloud vendor to provide. And so when you're in a position to make decisions, technical decisions for your team, or you're in a position to choose vendors or technologies, this is something to keep in mind. Right. So again, while I use Azure Machine Learning as an example, because that's what I use on a day-to-day basis, just think of this as more general capabilities that you should come to expect from a cloud provider and from a machine learning platform provider. Okay. So moving on. So I think when people talk about the cloud, they really, it's a very nebulous idea. They mean very different things. And so I think one of the things that don't often get mentioned is, a cloud services come in different flavors or different, different spectrum. I think the spectrum here, the dimension is how much customization you do versus how opinionated the cloud provider is. So at one end of the spectrum, we have infrastructure as a service, or also referred to as IaaS, and when people are talking about it. And so IaaS is, again, bare bones. Any bare bones cloud provider should be able to provide you with IaaS. So this is the ability to manage infrastructure through software. So being able to spin up virtual machines, storage, networking interfaces, all on the cloud. And I think example, again, all cloud providers fall under this example: Azure, AWS, GCP, DigitalOcean, IBM, Oracle, or Alibaba Cloud. So there is a core set of services like compute, storage, and networking. These are common denominator across all IaaS, right? And the reason to use IaaS is mostly to avoid taking care of hardware. So making security patches, making software updates, these are taken care of by the cloud providers. And so that's the one benefit of using IaaS. The other benefit of using IaaS is there is really, the cloud provider is not, has no opinions of what to run on these, on the provisioned hardware. So you can run any stack that you like. You can run Julia, Sas, Python, so you can configure your service however you need, right? So that's the advantage. The disadvantage is you're not really getting any acceleration, right? So you still have to do all the work, write all the software, all the glue logic. You need to write your load balancers, everything. Bash jobs, there is the only advantage is you can spin up a machine when you want to and pay for how much you use. So that's IaaS. So somewhere in between the spectrum is PaaS, also known as Platform as a Service, which is what I'll be talking about mostly today, right? PaaS sort of is slightly opinionated. It provides managed services. That means it takes care of things like networking, scalability, uptime, monitoring, and things of that nature. And the core idea behind platform as a service is it promises acceleration, right? So if you're leveraging a PaaS, you are writing less code than if you're using cloud as infrastructure. So things like App Engine, Heroku, Azure Machine Learning, which I'm going to be talking about, SageMaker, Dataiku, Stripe, these are all platforms. And the goal of the platform is they don't go all the way, right? You can't, there are no standalone applications, so you will have to still build on top of it. But the promise of the platform is you can build it faster. So that's the benefit of platform as a service. Finally, on the other side of the spectrum is fully configured software, right? So this is software running on the cloud. This is what you might have experienced more often. So Zoom is a SaaS service. Dropbox is. Some flavors of Azure ML are. So these are all software which, you know, they're opinionated. They work out of the box. So as soon as you buy them, you're able to use them. And these are targeted at more end users and consumers than platform as a service, which is more targeted to developers. And so you build on top of, you can build SaaS on top of PaaS, right? So that's what it is. So again, these are the differences. Again, when you're making technical decisions for the company, for your research organization, these are things to consider. So again, if you want customization, choose PaaS or IaaS versus SaaS. SaaS is pretty much, you know, you're licensing software. These are bought software, but now available on the cloud. So that's the model. So there's very little customization that SaaS provides versus PaaS. So things like MATLAB, all of these fall under PaaS. Okay. All right, so the second, again, this is very general terms, not specific to Azure. The second is Azure Machine Learning is not alone, right? So it's Azure Machine Learning is a machine learning platform. It's a PaaS software, but it is not alone. So again, this is the 2021 Magic Quadrant from Gartner that sort of tells you all the, sort of gives you updates on all the other machine learning platforms available today, right? And so there you see Microsoft, there is Amazon Web Service, which has SageMaker, Google, which has Google AI, H2O, NIME, RapidMiner. These are very popular sort of UX-driven platforms. And then you have all the vanguards like MathWorks, Databricks, SAS, which is the oldest of them all, and they're up-and-comers like Alteryx. So the idea is, sorry, let me go back. Okay, so again, I will demonstrate Azure Machine Learning, but this is no means the only choice that you have. But all of these software provide very similar capabilities. I think as I walk through Azure Machine Learning, the flavors of Azure Machine Learning, I'll walk through a UX approach and the UX flavor, also called the designer or studio. That is very similar to NIME, RapidMiner, Alteryx, which have sort of more of a drag and drop interface. The Azure Machine Learning Services, the SDK, which I'm going to talk about, that has flavors similar to MathWorks or Databricks. It's more of a software platform. And then there is Automl that is very similar to H2O driverless AI. So I think, as I walk through different flavors of machine learning, you can think of them as similar to different data points that you see here. And Domino is somewhere sits in between, right? So again, this is, you have a wide variety of choices in which you can, platforms on which you can work on, and these have different advantages, disadvantages, but so be aware of them. Gartner, again, produces an annual report. So this is for 2021. You can see people move around this quadrant, new people show up, and this is what you want to refer back when you have the ability to make a choice on the platform that you use. Okay, and this question, what do we look for when you make these choices? I think, again, it's more on the capabilities, more on gravity. So again, having I work on the Azure space, so talking to customers, the choice that is most often made is around data gravity. People tend to prefer platforms where data already exists. But I'll talk more about it during the Q&A. Okay, so I think I said acceleration is promise of platforms as a service. And I think what Azure Machine Learning promises is acceleration in your machine learning workflow, right? So workflow is probably sort of the term used in the industry, but you are doing workflows whether you know it or not, right? Again, when you might be doing these things differently, but any workflow is any repeated patterns that happen in your work. So when you're, for instance, writing a paper, you're still building models, you're still doing hyperparameter optimization, you're doing some experimentation. Your deployment step might be just publishing versus deploying a model as an API. But in an industrial setting, we have several additional steps. Your models and artifacts of your data science work don't exist in isolation. They are usually embedded within a larger application. So you tend to deploy your work that can be consumed by other people. And with deployment comes DevOps, continuous integration, continuous delivery. So as you update your models, you want new models to be shipped out, to be integrated into the application, show up on the website. So if you have a new recommendation system, you want to be able to surface that recommendation system through a web app that the user might be using, or through a mobile application that a user might be using. Right. So workflow is, again, any repeated process. So for instance, when I used to work at Nanigans, we had we used to build close to 18 to 20,000 models across our different customers. And so then typically we have a workflow or a template. And the only thing that changes between the models are probably the campaign, the advertising campaigns that the customer owns, but everything else is pretty similar. So workflows are very important. Anything that you do more than twice or more than once a day, I would say that's a workflow. Again, even if you're writing your paper, that is your publishing workflow, right? And so Azure Machine Learning will definitely accelerate that workflow. So workflows are very common in the industry, and platform as a service promises to accelerate this. So the second thing is, again, like I sort of referred to this, your models don't exist in isolation. And so when you are integrating it into a larger application, you have to be able to update your models pretty often, be able to integrate the models into deployed production systems. And so the kind of work that you tend to do, if it's software, this is called DevOps, right? If it's modeling, the new term is AI ops or ML ops. So here it just refers to the ability to write new software and deploy new software very quickly, right? So continuous integration, continuous delivery is now adopted even in machine learning world, right? So the kinds of things that you do is you might train and test 10 different models. One of those models tend to work well. You can sort of register the model, or version the model or tag the model. These are things that you can do. You can build a serving image. So this is the model plus serving code as an image, and then you can deploy that image onto different targets or hand it off to the engineering team that can do the integration. So I think, again, in an industrial setting, the most common surface area for your models is an API. So data science teams are either responsible for building and registering a model, and then the engineering team sort of productionizes the model, basically puts them in the path of serving systems. Or some teams, they build their own image, they build their container. So that's the handoff between the data science team and the engineering team. The contract is a container. They can ship new container versions, and the new container version gets deployed fleet-wide. But API, being able to expose your model as an API, this is sort of the common denominator across the industry today of how machine learning models get consumed. Okay, So this is, again, a very general, this is a common pattern across industry, nothing really specific about Azure. So now I'll talk specifically about Azure. On Azure, you have different ways of doing machine learning, of doing AI. So these are sort of organized as layers, I would say. Excuse me. So the first layer is pre-trained models. So these are pre-packaged APIs. So Azure has a computer vision API that can recognize 15,000 categories out of the box. We have speech APIs that do speech to text transcription in 40 plus languages. We have language APIs that does entity recognition, that does machine translation across 100 language pairs. We have search. So these are all pre-packaged APIs that you can use out of the box, but you really can't customize. There are some APIs like custom vision, custom speech that lets you bring your own data, but the choice of algorithms, the choice of modeling is fixed. You don't have a say in that, right? And so 90% of the use cases, again, developers trying to use a recommendation system or using text to speech, sorry, speech to text or text to speech, both ways. And in most of the cases, these are sufficient. These models are state of the art, automatically updated. Again, it's highly opinionated. You have a very strict API that you can follow, but as long as you can do that, you can use it out of the box. So again, a lot of the customers, Azure customers tend to use this. Again, these are targeted to developers. As long as you can write code, you can consume these APIs in any open API compliant, so that means 20 plus different languages. Any language that can make a RESTful API call, you can consume these, right? But I think, as the audience here today, I think we exist in that 10% space, including my team, where a pre-built AI, pre-built models are not sufficient. So you have to customize, you have to roll your own model, you have your access to your own data, maybe again, you might want to do computer vision, but you might want to do computer vision on infrared images, X-ray images, or you might want to do NLP, but in the tax domain, and or in the finance domain or energy domain. So these are all custom ML workflows. So this is the space I think the audience here is most likely to operate on once you work in the industry. And so Azure again provides several different options to build custom AI models. So that's what we are going to be talking about today. Is all our machine learning workflows are custom machine learning workflows where you bring your own data, you have opinions of what models that you need to use or what approaches that you need to use, and we will provide you a sort of different flavors of doing that. Again, on Azure, you can do it through Databricks. If you have, if your workflow is dominated by ETL and data ingestion, Azure Databricks is a way to do it. And now we have a new product called Synapse. Azure Machine Learning is sort of the catch-all. You can do any custom workflow on Azure Machine Learning. We will walk through 3 different flavors of doing that. Or you can just write your own code on machine learning VMs. So those are all the different flavors. Okay, so what I'll be talking about today is specifically Azure Machine Learning Service. There are 3 different flavors of Azure Machine Learning Service, I would say. On one side is you have full control. You can write any code that you like, use as much or as little of the platform as you like. So if the only thing that you want to use the cloud for is to spin up a VM and write your code in the VM, the Azure Machine Learning notebooks allow you to do that. If you want to do if you want to use some facility of the platform, like model lineage, data lineage, your code lineage, code versioning, all of that, you can use that. Again, optional logging, you can. So you can use as much or as little as the platform as you like. So if you want to get started out of the box, you're not really a machine learning person, but you have data. Again, let's say you might be running advertising campaigns, or you might have, again, you might be from again, you might be building models for insurance, you might be building models for ad campaigns, you might be building models for social sciences. All you want to do is to get the best model out there, not necessarily write a lot of code. Azure Machine Learning allows you to do that through Automl. But if you're somewhere in between, you really have opinions on which model to use. You want to say you want to split your data into training, testing, so you really want to inspect your data. We have the designer interface, which is sort of a drag and drop, still no code environment, but still allows you to do that. Okay, so I'll walk through these different flavors. So the first one is IaaS. So a data science virtual machine. So Azure provides you, so when you spin up a virtual machine, you can ask for a data science virtual machine image. So all this is again, either an Ubuntu or a Windows-based machine with some libraries and software pre-installed. And again, so this is slightly opinionated, but you can start with a bare bones Ubuntu machine and still work with it. And so the idea here is, as soon as you spin this machine, a Jupyter Lab is running automatically, so you can just log into the machine and start working, right? So you can expect TensorFlow to be installed, PyTorch to be installed, GPU to be configured. You get PyCharm, you have a whole bunch of Spark libraries, XGBoost, all of these are packaged up. So this is one way, but there is really no opinion or guidance of what code to write. So you can build your models anywhere you like, bring your data from anywhere you like. So this is, again, machine learning infrastructure as a service. So just spin up a VM and start using it. Right. And I'll the other I'll walk through the demo. The other option is managed notebook. So here again, Azure Machine Learning provides you the ability to create notebook environments in the cloud. Right. So as part of the Workspace, you can create managed notebooks. The reason it is managed is, again, you don't need to install Jupyter. All the libraries are available. You can, you'll see you can change the compute. You might prototype on a CPU machine, but then do actual full training on a GPU machine. You can change the compute independently of your notebooks. You can install your kernels. You can share these notebooks with other people. You can collaborate in real time. So it's sort of a managed notebook service, but again, really no opinion of what you write in the notebooks, right? So if you want to use common libraries, it's available. If you want to change the version, you can change it. You can change the runtime. We have a different bunch of runtime Spark versus CPU. But again, this is infrastructure as a service. So really no opinions from Azure about how to do your machine learning work. Okay. So that's IaaS. And again, I will be walking through a notebook experience. This will be the last demo. So this is where, this is fully custom code. You can write whatever you like, and then I'll walk you through it. And so the second flavor is SaaS, software as a service. So this is the flavor of Azure Machine Learning called the Designer. Again, you might, depending on which documentation or Stack Overflow you read, it might also, it's also referred to as a studio. And this is actually one of the products that I personally worked on back in 2015. And so I was there for the first launch of Azure Machine Learning Studio. And when I do the demo of the studio, I'll even show you some of the boxes that I personally worked on. So the studio, again, as the name suggests, it's sort of a UX interface. You can visually author your machine learning workflow. So there is, you have a palette. You get, I think, 90 plus different boxes to pick from. Between data transformation, between machine learning, we will, and so here, this is a no-code experience. You can stay within the studio environment, bring your data, train a model, even deploy an API, a fully scalable auto-scale API from within this notebook environment, right? And so, and this will be sort of the second demo that I walk through, and you can follow along. Again, I'll as I'm doing it, you can follow along and try the same or watch the recording. And I think on the GitHub page, I have links to some tutorial that you can follow. So this is, again, this is targeted to the end user. This is not to a developer. The end users here are data scientists that can do this workflow and publish an endpoint and hand off the endpoint to the engineering team or to the product team to integrate the model into serving, right? So it's a collaborative environment. People can co-author this workflow together. It's versioned. Again, all the data is versioned. Your experiments are versioned. You can add notes. I'll show you. I'll walk you through that. Okay, so this is fully opinionated. You have only 90-something plus options to choose from. Again, it's a lot of options, but that's pretty much it. You can still write custom code. There is a custom Python box that you can add and dump any code in there. But it's very opinionated about what you can do. Okay. All right, so the last flavor, the most customizable flavor is the PaaS offering, which is Azure Machine Learning Service. So this is essentially these are a bunch of backend services plus a Python SDK to use them. Okay, and again, the SDK is an optional component. You can use the SDK to build your models, or you can use the SDK to do the science portion of the data science, being able to version your code, version your models, version your data, version your deployments even. So you can actually, if you use the full extent of the SDK, you should be able to go back from a prediction to a API version that produced the prediction, to the model version that was deployed on that API, to the experiment that produced the model, and back to the version of the data that was used in the experiment. So you get full lineage and provenance of predictions. And so, usually our financial customers, our customers in the regulatory environment, they really love this feature because they can go from, they can explain a prediction all the way back to the source data that produced that prediction. Right. So, but again, all of these are optional components. You don't have to use any of this, or some or all of these. Right. I'll quickly walk through the features. So Azure ML Service. Again, this will be sort of the second demo. So it provides a bunch of ways to manage different assets in your workflow. So things like models. Experiments is where each experiments capture individual runs of your notebook or of your code. You can produce pipelines. So you saw the visual authoring pipelines. You can produce similar pipelines in code. You can pick different compute targets. So you can share compute targets. So for instance, an entire lab or an entire team can share a compute cluster, and then the jobs are sort of queued behind. So you can package models. You can package train models and code as images. So images can be deployed. And you can also manage your data from this workspace, right? And so again, these are all optional components. You can, there is really no opinion of which framework that you use. You can use the SDK from any of these frameworks. And again, this is very similar to, I would say, SageMaker or Google AI. So Google AI works in, you can use sklearn models, PyTorch models, TensorFlow models. You use the components of the SDK to manage your assets. So you can manage your model versions, you can manage your deployments. So it's that way. You're free to use the software that you're using, but use some features of the platform. Okay. The other ability it provides is training infrastructure. You can, like I said, you can share the training infrastructure. You can share a compute for notebooks. You can share compute for training. You can share compute for deployment, and so on. And this compute can auto scale. So that's the feature. Again, optional feature. You don't have to use it, but you can if you want to. All right. So the other features, AutoML is the first demo that I'll walk through. This is again an optional component of the platform. It allows you to bring data and some opinions of what you want to use. AutoML takes care of model selection. Within every model, it can do hyperparameter optimization, and you can deploy the models right away. So you can iterate through hundreds of models and deploy the best model without writing any code, or you can still customize steps here. So I think these are sort of the example models that you can sort of cycle through. For each of these models, AutoML tries different pre-processing steps. So for text, it has a bunch of pre-processing steps. It can try like hashing, one-hot encoding, embedding, and for numerical things, it does things like max scaling, Z normalization, a bunch of pre-processing steps. For each of it can try out different models, and for each model, try out different parameters, and so on. So it really takes most of the bulk of your work. Again, if your output is a model, if you're writing research papers about a new model, then you don't want to use it. But if your research paper is in social science and mechanical science, or could be a marketing science, where the purpose is to get the best model out and not spend too much time with machine learning, AutoML is a good way to do it, right? These are the kind of things that you see. For instance, here, the best model is sort of an ensemble model, but you will see it all tried hundreds of models, each of them metrics of all of those models. It has tried out different pre-processing steps and different model options, right? And I'll walk through, this will be the first demo that I walk through. And you can use a UX, you can do it in code. Again, really no opinion of where you use the SDK, right? Okay, finally, like I said, experimentation, I think, so I would advise, even if you don't use any of the platform step, I would recommend to use your credits to use the experimentation features, because this is really the science portion of your data science, right? So again, you might miss writing things down. You might forget which version of the training code, which version of the model it corresponds to. With model tracking, with code snapshots, you will be able to trace back predictions all the way to the data, right? I will show you, so every experimentation run is logged. So you can, after the fact, recover the entire code that was used to produce that model. So I would say if you take back nothing, but use the platform for experimentation and model management. Again, Azure Machine Learning is one way to do it. MLflow is another way to do it. Azure Machine Learning integrates with MLflow. They're interoperable. You can use MLflow with Azure Machine Learning as a storage backend, so it works multiple ways. All right. Finally, there's a model management. Did I skip one? Sorry, let me go back. Okay, so model management is another. You can version your models, so you know which version of the models the predictions are using, and go back all the way to data. So similarly, so you can use Azure Machine Learning for your entire, workflow. So that's the idea here. You can use any components. You can use pre-trained models. You can use experimentation. Use it only for deployment. So you can produce notebooks completely outside of Azure Machine Learning and use Azure Machine Learning only to deploy your APIs. So that is also possible, right? So all components are optional, right? Then there is the compute targets. We allow you to use many different kind of compute targets for serving. You can deploy onto IoT devices. You can deploy your image models onto FPGAs natively on Azure. So again, all optional components. So you can train your models in Azure ML and take out the models. So I'll show you how to export models. So you can use the graphical user interface, but then get the model out of the platform and deploy it anywhere you like, right? So if you have an edge device, if for instance, we have customers that they really like the platform. They do all the model management and then deploy it on on-premise clusters for better latency. So that is all possible. Okay, so that sort of brings me to sort of the end of the presentation here. So I think so I mostly talked about Azure Machine Learning as a way to boost your data science productivity. So this is the promise of PaaS. So any PaaS that you go and talk to, again, could be Dataiku, Domino Data Lab, SageMaker, Google AI. Your question should be, how does it accelerate your workflow? What can you do better, faster? Can you go from running 1 experiment a day to 100 experiments a day? I think those are the kind of questions that you want to be asking. The goal will be to increase your rate of experimentation and therefore your output. I think things fundamentally change. Like if you're able to produce 1 model a day, or it takes multiple days to build your model, your research is done very differently. You're more, but if you can go to multiple models a day, you will do research very differently. It fundamentally changes how you work. So speed produces productivity, right? So you will definitely, you can try out more experiments, you can try out different things. So the goal, again, for your research group, again, when you join the industry, for your work group, this is the question you should be asking on the platforms that you work on or the platforms that you buy, is how does it change your rate of experimentation? And does it make it easier for you to get your idea to production, right? I will show you going from training models to deploying it as an API, all within a notebook environment as code. So does that, again, that changes your ability to experiment. So in some cases, you really need to push things to production. For instance, a recommendation system, you have to deploy it to live site to bring it in front of users in order to be able to collect performance data, right? So there your rate of experimentation is limited by your rate of deployment. And so again, does your platform allow you to increase your rate of deployment? So those are the kind of questions that you should be asking, right? So that's pretty much your sort of workflow. Again, Azure Machine Learning, again, is an example. I think in generality, do your platforms support all of these? Or again, managed compute, can you share your compute to reduce your cost? Can you do DevOps? Can you integrate with the larger software ecosystem that you're part of? Production teams, product teams, and support for open source frameworks. So with that, I will stop here for a few minutes. Before that, I think I want to bring out, so while I answer Q&A, for people who haven't had the chance to look at the GitHub, please go visit the GitHub page. There is a preparation step. And provides you a way to get free Azure subscription as students. So there is a student link. So if you sign up with your UBID, you should be able to get $100 of credit. Even otherwise, you get like $200 credit but you need to give a credit card. So if you can just use the $100 credit, again, this, even if you keep the demos up and running, it'll be in the order of about $10 a day or so. So you have a week of experimentation that you can do after the demos, right? And so with that, thanks for pasting the link. I'll push the preparation link too. People can do this, and I'll now. So while folks are doing that, I'm happy to take any questions. So I'll take about 5 minutes or more of questions before I switch to the demo. Right, any questions? Again, use either the chat. I'm monitoring the chat on a separate screen, or I think volunteers will call on you too as well. Any questions? No? Oh, there's some questions in the chat. Let's see, did I answer? Okay, I think what aspects do we look for when we choose cloud service providers? I think I covered that. Again, depends on your workload, on your workflow, but I think the things to consider is what acceleration do they provide? I think that is the key question. And then if you're part of a larger organization, there is also the cost that comes into play. All right, I think recorded lectures, I think.
We will answer it in due course. Yeah, we'll send them email when the recording is available.
Great. Okay, I think I covered a lot of material. Any questions, feel free to raise your hands or just speak up.
I think even for somebody that's learning stuff, the provenance and the ability to go back and forth, I think that'd be useful for students as well, right? Like
yes,
not just
yeah, absolutely. And if, like I said, if you use nothing from this talk, I would say definitely pay attention to model management and data versioning and model versioning. So I think that you can still use as part of your research work. I'll show you when I do the notebook experience. It's a very small snippet of code to be able to record anything from your experiments. So as you run code, you just, instead of using logger.info, you will just use azureml.log, and things will persist. Your code will be captured, so you can recover that piece of code anywhere you like. And your $100 will go a really long way if the snapshot and versioning are the only thing that you're using. And I don't think there is a time limit on your $100. So if nothing, then just use, again, it'll help you do the science portion, reproducible research. Great. Okay. With that, then are there any other questions? Oh, there is a 1-year limit on the credit. Okay. But again, if it'll go a long way. You just spend a few dollars a day, and then again, I'll show you most of the compute that you spin up is used only on demand, and the compute ramps down when you're not using it. Okay. Great. So I'll walk through the preparation steps. So the first thing, again, in order to use Azure Machine Learning, you need to be an Azure subscriber. And like I said, you can go to the students portal to sign up. Once it takes you to the sign up page. And once you do sign up, right, so you should be able to log into a portal. So the Azure portal is, again, this is very similar to the AWS console. This is, or the GCP product page, project page, sorry. And this is sort of a laundry list of everything that you have. So for instance, I have the root of all your resources is the subscription. So your subscription it's sort of a billing entities, right? There's a bunch of subscriptions here. And I have a subscription specifically for the UB work here. And so subscription is sort of the container. This is sort of the billing container. This is how you get charged. And again, this is, I would say for AWS, this is your account, right? So your billing is associated with your account. So again, you might not have your individual subscriptions. Your organization might have a subscription. Your research group might have a subscription. But once you sign on to Azure, this is the portal that you get into. And so from here, you can create a resource. You can create anything and everything available under Azure, right? Okay. So again, I think, so this is going to be sort of a hands-on demo. I hope you guys follow along. And for this part, feel either put your questions on the chat or feel free to speak up if you have any questions as I walk through this. Okay. All right. So this is sort of orienting you to the Azure portal page. So again, this will be very similar. Once you have a subscription, you should be able to come to this page, right? And again, if you're having trouble, again, push it on the chat. I'll do my best to answer. All right. Any questions while people are doing the step? Okay, definitely feel free to speak up. I'm very comfortable with silence. I can stay quiet for a long time. Okay. All right. So the first step is a subscription. So if you're using your $100 credit, you should have a subscription. So this is the subscription that I signed up for. So this is a container. This is a sort of a billing entity. This is not how you organize projects. So you should definitely. So for instance, I've been running this, I would say, since maybe last Thursday or Friday. I've just run up $10. So your $100 will go a very long way. Okay. All right. So so the first thing that you do in the container, again, is the font readable to most folks? Okay. All right. So below a container, you have a resource group. Think of a resource group as a bunch of related resources, right? So again, in AWS, these are called projects, and in GCP, these are called projects as well. So a project has an identity. On Azure, these are called resource groups. So a resource group are things that are related to a single project. So so for this demo, think about this demo as a resource group. This uses Azure Machine Learning. It uses storage. It uses a bunch of container instances, container registry. These are all resources. These are all infrastructure pieces that are related to a single project. Okay. So let me go back to the subscription. So the first thing that you want to do is maybe create a new resource group. All right. So we will create a new resource group. It takes you to a new resource group page. So a resource group is attached to a subscription. So I will just say you can give any resource group. Again, this name is not has to be unique to your subscription. So there is really no constraint. Resource groups are attached to regions. So again, these are Azure data center regions typically, but nothing really constrains you from having individual resources that live somewhere else. So the region or the data center attached to the resource group has very loose association, right? So pick anything that you like. Typically, again, for people in this neighborhood, and pick East US, so your latency and response will be low and responsiveness will be high for anything that you create. Again, for people in the West US, again, Azure has 100+ data centers, so pick any of your choice. But I'll pick East US. So, and again, tags are a way, is to tag your resource group. So things, again, if your research group has many different projects going on, typically you can tag it saying, this is me, this is the project, is, let's say, and so these are just a way for you to remember what this resource group is about. And again, in an industrial setting, these tags are enforced. So you need to provide expiry date, your reporting group, or your cost center, your billing code, and a bunch of things. And Azure can enforce policy on the tags. But for now, these are just informational, right? Once the resource group is created, so now we have a container for our project, right? And the first thing that we will do is go create a machine learning workspace. So this is the primary resource that you will be using. Again, feel free to go in your time, go create VMs, go create storage, Databricks clusters, anything of your choice. Anything under Azure with your $100 subscription, there are really no limits to what you can spin up. Again, things will cost more if you're bringing up a Databricks Spark cluster. Of course, your billing will be much faster. But otherwise, I think for this demo, the only thing that we will need is a machine learning workspace. So just search for machine learning. So again, so the things that you can create here are things that is first-party things that Microsoft provides, but there is a whole bunch of things that third-party provide as well. So there is a Azure Marketplace. You can spin up anything in the marketplace as well. Again, there is really no restriction. Okay, so this is where you want to be. So go ahead and click create. So this is creating an Azure machine learning resource, right? So or a workspace. So workspace is the container for all your machine learning assets. So the important thing to note is the workspace is a shared asset. So again, you might create a workspace per project. You might create a workspace per research team. You might create a workspace per department. But multiple users can share the compute within the workspace. So I will give a workspace name. Let me just say. So a workspace requires a bunch of Azure resources. So it requires a storage account, a key vault for storing your secrets, app insights for logging, and you can also create a container registry, but it'll create one. Let me go. There you go. All right. So this is sort of the dialog for workspace creation. You can again pick networking. So we will not really do that. In networking, you can have public endpoints, or you can create a VPN and have everything sit inside the VPN. So for now, we will just review and create. Right, and so this is just validating all the settings. Once it's valid, you can create. So what create does, it goes creates the storage, it goes creates the key vault, everything that is needed by Azure Machine Learning. This should take this should take about a few minutes to deploy. You can monitor the deployments live here. And again, I think this is a good time for me to answer any questions. So I will use a workspace that I've already created. So in the subscription, in my resource group here, so I created 3 resource group. The one that I just created was CDSE Live. I also have a resource group already created, which has a Azure Machine Learning workspace. All right, I see a question. So again, it's a good time to ask questions. So you can monitor the creation. So you'll see this bell icon that's going on. So can we share data among the resources, or is just computation? No, the machine learning workspace is a container for data, for your models, and for your compute. So you can definitely share data across different people within the same workspace. And generally storage is a shared, you can provide, you can override permissions on the storage. You can restrict storage to people who have access to the resource group, to the subscription, or you can open it up publicly too. You can host websites from Azure Storage. Good. All right. So again, so this is where you need to be. So so I think this was created. So if I go to the resource, you will see a very similar. So a Launch Studio will bring me back to the same. Right. So I'll actually use the not the live one, but I will use the one that's already created. Any questions so far? Okay, so this is your Azure Machine Learning workspace. I'll sort of orient you in the UX. So again, this workspace is something that lives on Azure. This is the UX. You definitely don't need the UX to access your machine learning workspace. I'll show you how you can connect to a workspace through code, right? But this is true of any Azure resource. So you can control your VMs, you can control your storage, everything through code, but you can always use the portal to come and access it. So, so this is the home for your machine learning assets. So Azure Machine Learning, like I said, provides different experiences. We will walk through each of these experiences. There is so these experiences that I talk about, these are authoring experiences. This is how you make changes to your experiments or to your code. So there are other assets that you can control. This is a container for your data sets. So you can register and share data sets across different people in the group. So there is a bunch of data sets. This is a container for your experiments. So these are all the experiments that you run. So an experiment is just a named piece of code. And you can track. So for instance, I have created an experiment called a notebook run. Within that experiment, there are different runs of the experiment. So this is how you track different runs of your code. You can track pipelines. So pipelines, again, are pieces of code. So when I come to the UX, all of the UX are pipelines. This is the home for your models. So you will see there is a model. You can track different versions of the same model. So, these can be associated with a run ID. So you can, so again, you can track back the model. So in this case, this is an AutoML model. I can track it back to the run ID. From the run ID is just an experiment. I can go back to the data that produced it, right? So this is where the provenance and the lineage comes in.
Sharat, you might want to make the screen a little bigger.
Okay.
A little.
There you go.
Yeah.
All right. So apart from tracking, so you can track data sets, experiments, pipelines, models. You can also track endpoints. So endpoints are your web assets. So these are deployed models. So I have a whole bunch of deployed models, and I'll be walking you through a deployment too. So it's very easy to, every deployed model has a URL, a REST endpoint. It has OpenAPI compliant JSON file. You can test a deployed model. So here's a model that I've previously deployed. I can just call test on this. So you will get predictions. You will get actual predictions. You get sample code of how to consume the endpoints. So you can consume these endpoints in C#. You can consume these endpoints in Python. These are sample codes to consume your endpoint, and so on. So then you can manage different assets in your workspace. So compute is one of the things that you can manage. So I'm running a compute instance. This is where I'm running my notebook. I also have a compute cluster. This is where this is a shared cluster where the entire group can run their jobs or experiments. You can schedule experiments to run on this versus run locally in your notebook. Then I think this was a question, shared resource. You can share, again, these are different storage spaces that are shared. These can be blob stores. These can be file shares. These are NFS mounts that you can use you can mount it on your computer, mount it on your cluster, on-premise cluster, and so on. And then you can do a bunch of things. So this is a workspace. Any questions about the notion of a workspace? All right, there is some question. Is there any limit on the slot size of the web app? No, you can use any VM size allowed on Azure as your compute node. So you can use HPC nodes that have 120 cores. You can use GPU nodes if you want to do inference on deep learning models. So there is really no limitation. Any VM that you can spin up is a possible target for your model endpoint or model API. Okay, any other question on the workspace? So again, so the workspace notion is very common. Again, if you're using Domino Data Lab or H2O.ai, Data Robot, the notion of, or even Databricks has a notion of a workspace. So a workspace, think of it as just a container for your machine learning assets. Okay. All right. Any questions? Okay. So what I'll do now is maybe walk you through a bunch of demos. So I have three authoring experiences. So the first one is AutoML. So for this data set, I will use the same data, automobile data set. So the idea here is you want to predict the sale price of an automobile based on different attributes. I'm keeping the problem very simple, so as not to distract attention away from the workspace and the tooling. And two, I will be using the same example across all the three authoring environments. So you will see how your code changes. So again, if you go to the GitHub page, you can see this is coming from the UCI machine learning repository. There is also a CSV file that you can reference in your code. Okay, so the first experience that I would like to talk about, I think this is the no-code experience, so which is AutoML. So again, this is targeted to folks whose primary output is not a model, but a primary output is some applications of models, right? So again, mechanical sciences, marketing science, social sciences, any place where you really want the best possible model, but you really don't want to invent a new model for the sake of your work. Right? So that's that. So we will use AutoML through the UX experience. Yep. Correct. Okay. Thanks for the time check. Yep. So we'll use the US experience for AutoML. So again, here the notion of AutoML is you bring your data, you bring your opinions of what models are possible, and then you let the cloud do the compute for you. So that's the idea. I'll show you as I walk through this. Let me create a new AutoML run. So the AutoML run, the first thing that I need to bring to the AutoML run is a data set, right? And again, let me copy the URL here. This is the CSV file. Okay, so the first thing is to create a data set. I can, of course, I have the data set here already, but I'll show you how to create a data set. You can create a data set from local store, from pre-registered data set, or again, you can use some sample data sets. There are a bunch of data sets for experimentation that is available. Some of them, like the NYC taxi data set, these are pretty huge. So these are gigabytes of data set that is hosted for you. So, so I'll just take you through the motion. So I want to do it from web files. I'll give the CSV. I will call it again CDSE live. This is a tabular data set. So the thing to notice is you have a version. So Azure ML allows you to version a data set. You can override a data set with different versions, and it'll keep track of it. And so when you run an experiment, it has an association of the data set used. Okay. All right, so with the data set, Azure ML doesn't really know about the data set, so you have to go inform sort of what the data set is about. It's in this case, it's delimited, it's UTF-8 encoded. The header is coming from the first file. You can skip rows and so on. So this is just informing AutoML about your data set. So next, you can override the types for the data set. So first of all, you can turn off columns. So I don't want symboling, or I don't want normalized loss. You can, so you see some example values, and you can override. So this has detected it as a string. I'll keep those. There are a bunch of things that are detected as decimal. I will keep those. There's some that are integers. That's fine. So in most cases, it has done a good job of detecting the types, but you can override it. So for instance, this price has to be decimal. This is our target, right? In some cases, this is decimal, so on. Okay. So again, it's not perfect. In cases there are missing values, in this case, the missing values are question marks, and that's why it's detected them as string versus integers. Okay, so this is all about the creation of the data set. Right, I'll go create this data set. And so this is now registered. I can reference this data set from different experiments. In fact, I can reference this. That's all this is doing. So I will ask it to reference this data. So the next, so this is, I can ask it to use a experiment or create a new experiment. Again, I can have different runs. So I will call this experiment CDSE live. And excuse me. So I pick the target. I want to predict the price. And I can pick a compute. So you can always create a new compute. A new compute will take you through a dialog of selecting a VM size. So this answers the question, any VM size is allowed. You can pick things like F4 that have 8 cores, but you can, in this case, I only have a limited amount of cores available. But so I will use a pre-existing compute. You can pick a GPU compute, low priority, dedicated. Dedicated is priced higher. Low priority means it's preemptible. You might lose this at any time, but it's 20 to 30% the cost of dedicated machines, right? So typically, again, if you're running compute, I would recommend use a low priority compute. So in this case, I'm using an existing compute. Okay, I'll go through this. And so the only thing Automl needs to know, it's a target column. And the kind of problem that I want, right? So in this case, it's a regression problem. This is all. So again, this is very similar to the SageMaker UX or the SageMaker API, where you just have to bring your own data, pick a type of a problem. So in this case, it's a regression problem. And that's all pretty much you need to do. At this point, I can press finish, but I just want to show you behind the scenes, you can go override a bunch of things about Automl. So I can pick the metric. So instead, I want to optimize on root mean square error. Here are the list of algorithms that are available. So in fact, you can eliminate some of them. So if I don't want, for instance, to run SGD, I can block it. I don't want to run KNN, I can block it. You can pick validation. Let's say I want to do k-fold. I want to do two-fold validation. So these are all the options that you can control through code or control through the UX. Okay. So with this, in fact, let me also. So there's a bunch of exit criteria. So you can say, run. I have this compute. This compute has like 4 nodes. Run. Keep running different combinations for up to 3 hours, right? In this case, I will just say up to 15 minutes. Or you can say run up to meeting a certain threshold, right? And it understands that root mean squared lesser is better, R squared more is better, and things like that. So this is my setting. Now, all I can do is to say finish. So I will walk through. It'll take a few minutes for it to start running. So I'll walk you through a finished experiment. But once this starts, so you should be able to see a whole bunch of things happen. So right now it's just it's trying to schedule the job and on AML compute. And so once it starts, we will walk through a finished experiment. So there's a question, does Automl fit the data with the weights of a pre-trained model, or is it some sort of training, fine-tuning? So in this case, for AutoML, it is starting from scratch. So it's not a pre-trained model. These are all scikit-learn or deep learning models, which is starting from random weights and fitting on the data that you provide, right? So, so this is going to start. It takes about a few minutes. So what I will do is walk you through a finished experiment. Right, so you will see now it's running actually. So, but there are. So let me take you through a finished run. So this will take a few minutes. So you will see this took about 38 minutes to run. Again, because this was doing hundreds of experiments, so it timed out. In fact, so the kind of things that has done it's giving me a root mean squared error. It also gives you all the other metrics that it has computed, right? R square metric, Spearman correlation, all of it. So behind the scenes, what has it done? This is the metric it was trying to optimize, right? And the algorithm that it has picked is a voting ensemble model, right? and we will walk through the model itself. But behind the scene, what it has done is it has evaluated a whole bunch of models. So in fact, so this is about 25 per page. So this should be close to 70 plus models, I would say, right? And what, so it understands a bunch of things about the problem. So first, it knows that this is a regression problem, so it is picking from a choice of algorithms. Two, it knows, because you annotated the data, it knows it's a combination of categorical columns and numeric columns. So it is picking some sort of pre-normalizers or pre-processing step. So in this case, it's max scalar. Let me just sort it by the metric. So it's picking a max scalar. So for a given choice, so in all of these cases where it picks the max absolute scalar plus decision tree, it is changing the individual parameters of the decision tree, right? So it's sampling the parameters. So it's doing three things: picking the choice of pre-processing, picking the choice of model, picking the choice of the model parameters, right? So, and it is scheduling these jobs on the shared compute, and it is going through hundreds of different combinations, and it exhaustively goes through each one of them, right? So, and at the end, it's suggesting that I pick the best model. The best model is a voting ensemble here, right? And it gives the best mean normalized scores. I can look at the other things, but there is a whole bunch of things also. So when I picked the run, I also said explain. So it provides explanation by default. So this is the ensemble. There are two models in the ensemble. I can pick an explanation. So this is a light GBM model. And I can look at the aggregate feature importance, right? So I can give it a bunch of models. It's giving. And so you will see, even in the model, it did some pre-processing. It is not using the raw column names, but you will see it's for numeric columns, it's mean imputed. For categorical columns, it's hash encoded. For fuel system, there is character grouping. There's a bunch of things that it's doing intelligently on this, right? And of course, it gives you the feature importance. You can get breakdown of the importance on different cohorts. So for instance, I can add a new cohort. Let's say you want two cross sections of data. You can get a side-by-side comparisons on that, right? So in this case, now it's giving you feature importance across two different data sets, but these can be different. So it's doing a whole bunch of things. So I now have a best possible model that can be trained in a 3-hour timeline, right? Again, you can give it a day, or you can give it certain cycles or 100 different runs. It'll give you the best possible within that compute bound. So we don't stop here, right? So I can pick the best model. This is the best model that I have. You will see it has a bunch of metrics. I can view the metrics as chart. I can view it as a table. And it's logging everything. In fact, so the fact that this is a run, that means it's an experiment. I have a snapshot of this. You can download everything. You can download all the run, any images that were produced. In this case, there are no images that are produced. So the last thing I can do is actually deploy this. So right from the UX, I can say, I want to, this model looks good. I really want to deploy it. I call it CDSE best model. And I can pick a deployment choice. If I have a shared cluster for deployment, I can choose Kubernetes clusters, or in this case, it's a dedicated deployment. So it just brings up one VM to serve this model. I can deploy it. You can pick stuff like your SSL, or this is the memory capacity, and deploy. So you are going from training a model to picking a model parameters, choice of model selection, and this is actually deploying a real live site endpoint for you to query, right? So let me go to the endpoint. So once it's there, you should see an entry now for CDSE best model. Again, this is still being deployed. you will see deploy state is transitioning. So I will pick a deployment. So this is a deployment that I produced earlier, right? So I will show you sort of the lineage. So this is the model that was produced. I will click on the model. From the model, I know the experiment that produced it. And from the experiment, I know all the run IDs associated with that experiment, right? So this is how I can track down the different experiments. So this was produced from this finished. This is a different model. Okay, I'll walk through the design. So so this is how you can do the lineage. So let's see if this model is deployed. It's still transitioning. So okay, let me switch to a already deployed model, which is automobile pricing. Okay, so now I can test this. There is an endpoint. I think we already tested this. For all of the sample data, you can get predictions. It even gives you sample code of how to consume this prediction and endpoint. So without writing a piece of code, I went from data set to best model to producing a API that can now I can hand off either to the product team or to the engineering team. And this API is sort of even protected by authentication keys. Okay, so that's the AutoML experience. So I will stop here for a few minutes for questions. Any questions? Right, and so and it's smart about the pre-processing. So if you have a whole bunch of string variables, string columns or categorical columns, you can one of the choices is you can pick an embedding model as a feature preprocessor. Okay, no questions. All right. Okay, how are we doing on time? Okay, we have another half an hour. So again, feel free to, I'm monitoring the questions on the chat. Or I'll ask one more time and then proceed to the next one. Any questions so far? Okay, all right. I think the AutoML experience is for somebody who doesn't want to use any code, just wants a good model out. But now I am a data scientist. I really want to spend less time modeling, but I still have opinions of how to model. And so for that segment, we have this designer experience. So designer experience is the drag and drop. So I can go to the designer. So designer allows me to either start from a bunch of templates. So I would recommend you to go look at the feature importance. This is something that I worked on 5 years ago. There are a whole bunch of templates that you can start with. And so, for instance, this is exactly the kind of problem that I'm working on. I can go look at this template. I'm doing regression on automobile pricing. So a template provides you sort of a predefined workflow that you can go and customize, right? And so in this case, again, this is an authoring environment. So I'll just where you can define your machine learning workflow. You can ask it to use the same compute as what you had for the other one. So all of this is running on the same compute. Multiple people can run multiple experiments. You can have, again, it's version, so you can put your data sign. You can put your description here. Each run of this workflow is versioned, right? So what I'll do, so I'll just walk through this experience here. So you have a palette, or these are called assets. You have, again, 100+ assets here. You have assets to do data transformation. So you will see some of them. Column selection is one of the assets. You can do things like SQL transformation, clean missing values, a whole bunch. You can pick a whole bunch of things from the palette here for data transformation. So we have 2 data transformation steps. You can, so again, this is a visual environment. This is data sets. You can pick any pre-registered data set. So you will see CDSE Live is available for you. You can also pick some from sample data sets. So the automobile is from the sample data set. Right, so I can visualize the data set. So in fact, I can go say, look at the data set. There you go. So this is, it sort of visualized the distribution of the different columns. There are 26 columns, gives you sort of the histogram, and sort of gives you, you can cycle through the entire data this way. Right, so this gives you, so looking at this, there is a whole bunch of nans and the normalized losses. So maybe that's why I want to remove that. So I can do that by bringing this data transformation box or asset here. And this has settings. So this is saying, in this case, it includes all columns by default. You can exclude some columns here. So maybe there's another column I want to exclude. I maybe want to exclude symboling. Right, you can say this. So, so the interesting thing to note is this understands the data flow even without running this. So the schema is propagated even without running the code. So this understands now that I can select the data. And so now when I inspect, so now if I want to do clean missing data, it understands the available columns are different. Right, so this column will be missing here, right? So let me say all columns. So the schema propagation, the schema runs through the graph even without running the actual code in the graph. So that's something very unique. So I want to clean missing data. What I want to do with the missing data is remove the entire row, right? So that's what I want to do. I want to split data. Again, these have different parameters. I want to split into, let's say, 80 and 20. You can do stratified split. Stratified split just means it understands the label distribution. So, so you can say stratified split true, and then if it's a classification problem, it will split each label equally, each label value equally. Right, and it has a train model box. So the interesting thing about the train model box is you can select a whole bunch of training algorithms, right? And it has a common API, and so you can pick and choose. So for regression, instead of a linear regression, so let me just delete this guy. I don't like linear regression. This is least square, so I will actually choose boosted decision tree regression. Right, and here I can pick parameters for the decision tree. These are okay parameters. You can do quantile regression. So again, this is one of the boxes that I personally wrote. So take a look when you get time. So in this case, I have picked decision tree regression. I can just connect it. I can pick from here, connect the box, and scoring. Append scoring, and evaluate understands. So it knows that this is the model metadata is propagated across a graph. So evaluation knows that this has to run the R-square metric or regression metrics. It understands the score column name. So all of those metadata is propagated. So this is how I define a graph. And then I just click submit. And so this is really doing, so again, this can be tracked as an experiment. So I will just say this is a designer run. Right. So I can monitor this experiment. I can come back to this experiment. So once you run an experiment, everything is frozen. All the parameter setting that you chose, the snapshot of the data is permanently associated with the experiment. So at any given point in time in the future, you can come back to this experiment run. Right, and so everything is versioned, and so you can, and it's read only. So that's where the provenance comes in. Once the experiment run is started, if it succeeds, everything is frozen. So that's where you get, there is no way to go and alter back the metadata associated. So if by accident, if you get a really good parameter setting, that is preserved for posterity. Okay, so I will let this run. So you will see actually because it's a graph, it has a notion of dependency. So things that don't depend on each other run independently. So the select columns and the decision tree, they're running independently. Okay, so this is going to, again, this is scheduling it on the same compute. It's going to run one module after the other. It'll take some time, so I will go back to a run that has already finished. Okay, so let's go back and see one of the runs. Let's maybe, okay, so let me, I think this has finished running. This is exactly the same experiment. So you will see boosted decision tree, everything has run. So once you run it, you can visualize the score. So you can visualize it as a data set. So what it has done is adds a new column that you can use, right? So these are all the original columns, and you will see a new column that is this predicted labels. And it's pretty close to the actual labels, so not bad. So you can, so evaluation knows that there is a scored column. It knows about what kind of model this was. And I can look at the evaluation output. I can visualize the evaluation as a table, and you get all the metrics. So you get absolute root square coefficient. This is the R squared metric, which is a pretty good fit. Right. So this is how, again, you have an opinion of which model to pick, but you still don't want to write too much code. This is one of the ways that you do it. Right. So this is just training. You can still go all the way to production from this UX. Right. So I'll quickly cover that. So as soon as the UX detects that there is a trained model and the model has finished training, it'll enable this thing called create inference pipeline. Right. So create inference pipeline, it's creating so this is a training workflow. An inference pipeline creates an inference workflow. So I will just do this. So it's already created an inference workflow. This is how it looks. So this is, again, a different graph. So it has done a couple of things for you. Again, this is automatically done. So when you say create inference workflow, it transforms this graph into an inference graph. So in the inference graph, you need to preserve some things from the training. So one thing that you need to preserve is the schema of the data. So it preserves, it copies over a snapshot of the data. It preserves the transformation. So the kind of transformations that we did, which was removing columns and removing missing rows, that transformation is copied over. So, so this is a serialized version of the transformation, right? And this is the trained model. So the trained model has been saved as a data set and it is copied over. And then you score, and then you can evaluate a model or score the output. And the web service input, web service output is automatically added for you, right? Now you can go and run this and deploy it, right? So I will go say deploy it. I will deploy a new endpoint. I will pick an ACI just to be fast. So the deployment here is identical to how we used Automl. So from a consumer point of view, so from a product team or from the engineering team, there is really no difference in how the endpoints behave, right? So in fact, I'll show you once this thing is deployed. It's saying create deployments. I can go to the endpoints. And so this is the designer live. So in fact, the automobile pricing was, if you look at where I produced the model, again, if you trace it back, the experiment run will be a designer run. So, so you can consume, you can test the endpoint, you can try out a CSV. So I can just copy paste the CSV line here. And so you will see, in fact, it's produced from a designer endpoint because it says web service output 0. So that's what your designer set, right? So again, without writing any code, but using my experience in picking out algorithms and picking out splits, cross-validation, all of those choices I can make and still produce a consumable endpoint. And this endpoint can be consumed through code or through this test endpoint, right? With authentication. So there is security. This is a secure endpoint that a production team or an engineering team can use. Okay. So that is the designer experience. So again, there is really no reason that you need to copy a template. I can in fact start from a blank slate. I'll go to the designer. I can say blank slate and start the whole workflow from scratch, right? So this is just a clean blank slate. I can bring in my data sets. So let's say I want to bring in the diabetes data set and then try to assemble the graph from scratch. So it's right. So I wanted to do things like data transformation. I wanted to clean missing data. I can create this from the scratch. So there's really no difference between this experience and copying. So you can copy and edit, or you can start from scratch. So that is the designer experience. All right, I'll stop here again for questions. The last experience I'll show you is the full code experience or the notebook experience. So I'll pause here for any questions that people have. Okay, so then so you saw it took about maybe a few seconds for it to become live.
As you see research pipelines coming up with newer things, how often are these your library of available choices updated?
Good question. So I think the assets, so Azure Machine Learning has a release every 2 weeks. So, you know, in the best case, you will see new things crop up every 2 weeks, but typically not. This usually, you get new algorithms every month or so. But again, in the designer, one of the things, so if I create a new pipeline, so in the designer, you can bring your own model, right? So I'll show you one of the boxes that is available is a Python language box. So you can create a Python model here. This provides sort of so the API is provided. You can connect your custom Python model to the rest. So you can have everything that is pre-built except for this new fancy model, right? So you can bring your own code and connect it with the rest of the graph. So this is another thing that you can do.
Cool. That's nice.
Yep. So in fact, I think people sort of abuse or use the designer to bring up new web APIs pretty quickly. So they have custom Python code that they want to transform into an API. They just go to this designer, put their code here, and publish an endpoint from directly here. So you can also have custom R modules. So this is an R script, and you can interoperate all the pre-built modules with the Python modules with the R modules in the same graph. So again, typically this is the experience you will get from other providers. If you're using KNIME, if you're using RapidMiner, these are the popular ones, or Dataiku, you will get a similar drag and drop experience. And in some modules, some platforms allow you to publish from this interface. So I think, for instance, Alteryx has an ability to publish directly from the authoring experience. In other places, you have to sort of download the model and hand it off. So the experience differs across platforms, but this is sort of a full end-to-end. Okay, any questions? All right. Text classification, good question. So you can definitely do text classification in AutoML. So like I said, so you can pick a classification problem type. And when in the option for feature preprocessors, so you have the option to use embedding models as of one of the preprocessors. In fact, if you don't use embedding, by default, it uses hashing and TF-IDF. So TF-IDF and hashing are one of the options for preprocessing text columns. In fact, you can mix text and numeric columns in your data set. So that's how you can do text classification. Okay, any other questions? Great. All right, we have 15 more minutes, so I'll try to run through the final experience, which is a notebook experience. So a notebook experience is, so Azure ML allows you to spin up managed notebooks, but anything that I'm doing here, you can do it from your local notebook, right? So again, I will take an example. This is a managed notebook where I'm running this on a managed compute. So I can pick a compute, or I can create a new compute. Right, so this is exactly like a Jupyter Hub environment or a Jupyter Lab environment. So I can go, in fact, create terminals. This is just all that is doing is running on a VM hosted on the cloud. So all of the listings are available. So this is just a notebook. I'm bringing the same data set. And in fact, so you won't see any Azure ML flavor here, right? So I'm trying to download the data set. I'm importing pandas, NumPy, sklearn.
You might want to increase the size a little more, Sharat.
Oh, yeah. Oh, thanks. All right, let's see. Okay, is that better?
Yeah.
Okay, so it's the same data set that I used in the other two experiences. I'm just picking numeric features just to keep the notebook simple. This is my label. I'm reading it from pandas. I can. So again, this is a notebook experience similar to Jupyter Notebook. You can just execute, runs with the kernel that you pick. Yeah. So it's no different. The only difference is this is a shared notebook. Everybody who has access to the workspace can use it. In fact, you can edit it concurrently. So there is real-time collaboration that can happen. You can do Markdown. You can do. So in this case, I'm just doing a train test split. So I'm pushing it through a regressor, which is a random forest regressor, right? So nothing fancy here. I'm using the default number of estimators. I can do predictions, evaluations. So these are all vanilla code that you can run in any notebook. You can run an Azure ML notebook. In fact, you don't have to run an Azure ML notebook, right? So this is just a convenient thing. If you want, you can. The best thing about this notebook is you can stop it if you're not using it. You can pause the compute so you don't pay for it, and so on. So and the benefit is this workspace is available to everybody, so they can look at it. It's snapshotted. That's the benefit. So you can revert to a different version. Right. So now there is really no Azure ML flavor here, right? So this is a vanilla notebook doing regression. So this is more like an interview question kind of question, right? So it's very simple regression problem, plot, you get R-square metric. It's a good model. So now I can sort of now sprinkle some Azure ML through it, right? So I'll show you. So there's very little modification I have to do to sprinkle Azure ML. So the first thing I need to do is connect it to the Azure ML workspace, right? So the way I do it, I import Azure ML again as a Python SDK. I can just say workspace from config. If you're not signed in, it'll ask you to sign in. So now I am connected to this workspace. I have access to everything in the workspace, all the designer runs, all the AutoML runs, all the registered data sets, and so on. Right. So this is where the science comes in. You can start tracking your notebook run just by creating a new experiment. So so let me call it now C live run, right? Or CDSE. So now I'm creating an experiment, and I just have to say, so an experiment is a placeholder. So an experiment can have multiple runs. So this notebook, so I want everything related to this notebook to show up in CDSE live experiment. All right, that's the idea. And every run is a new run. So I will just say, so now I have now started tracking this notebook run in Azure ML. So in fact, if you go back to experiments, CDSE live is an experiment. A run, it's running. So suddenly now I have connected it to the workspace. Now, what are the kind of things that you can do? You can time your experiments. I can go to the run ID. So in the run ID, again, I can log metrics. I will show you. One thing is you can capture all the logs. But the best part here is I have all the code. So this is automatic version control for you. So as soon as you say start experiment, start run, it takes a snapshot of your code base. And so now this is now preserved for posterity. You can come back to this, data files, setting files, parameters, anytime that you like. Okay, so let me go back. So let's go, I'll come back to this experiment run. So we have started logging. So the rest, I didn't want to do that. So the rest, I can proceed as it is. Oh, why is it doing that? Okay. So, again, this code is unchanged, right? So the only extra code I had to write was connect to Workspace, start logging. Okay, I will run this. Training, I proceed as it is. I'm not doing anything different. Same code as before, vanilla piece of code. So now I can log stuff in my experiment. So one of the things I want to log is maybe the metrics, right? I can also maybe date, I can log value. So anything, again, however you're doing your journaling, you can do it via Azure ML, right? So now all of this is logged as part of the experiment. Right, so again, I can go back, I can look at the run details from here. Let me open up the run details in a separate tab. So suddenly now, in addition to the snapshot, this run, you will also have logs right now. Oh, I think you saw in the details. So you can add tags. So this can say, so somebody who has done this, again, if multiple people are collaborating, you can add tags. You can so you can query experiments by tags. So this is the metric I logged. This is the date I logged. So this is permanently associated with the run now. So now I can look at previous run and query by metrics, query by tags. Okay, let's go back to the notebook. So this is so if this is all that you do, I would say you will still get benefit of Azure ML because now you're doing reproducible science here. So I want to go further. I want to actually deploy this. So in fact, I want this notebook to become like my production notebook. This is where I will train models and deploy models. So in order to do that, I will just save a model. Right, I'm just saving the pickle file. And Azure ML, so this is now the second optional component I want to use from Azure ML is registering a model. So I want to import this model. Again, everything is happening through code, and you need to do a bunch of things to register a model. So in addition to registering a model, I'm also registering the schema that the model needs, right? So a model is associated with some schema. These are the inputs that the model should expect. I will go and register these. So now I will register a model. So I will call this C live model, right? So so now this model is registered. So now if I go back to the workspace, okay, let's go back to the workspace. So if I go back to the models assets, you'll now see a new model that is called CDSE live model. Right, and now this has a version. So if I go back to the notebook, register a new version, you will see a new snapshot. So everything is right once. So you can always go back to the version. So you can't override a version. So this will now register a new model. So you will see now there are two models. Right. So again, so this is great for reproducible science. So you will, at any point, you can go back. Now I really want to deploy this. So this is, believe it or not, this is all you need to do is to deploy this model as a service. So I will call it sklearn live service. So because I attached the schema to the model, Azure ML knows enough about the model. So it knows this is a scikit-learn model. It knows what is the pickle file needed. It will now go and create a live endpoint, which takes in the schema and uses the model to produce a prediction. Right. So if somebody wants to try this out, so when you're doing experimentation with the production team or with the product team, you can use a notebook experience similar to this. Deploy an endpoint directly from your notebook. Okay, this is taking time. So right now it's building an image. So image is just the model snapshot plus the code that is needed to do inference. Right. In fact, I will once this is done. So let's go to a deployed endpoint. So I'll show you one of the, so this is sklearn service. So this is a model that I previously deployed using the notebook, right? I can now test this. This has a very similar interface. I can test this, you'll get predictions, you can consume it. In fact, so you can similarly consume it with any of the endpoints, right? So you'll see deployment logs. These are all the things that are happening behind the scenes. So this is an endpoint. You have a model. In fact, this is a model version 6. I can go here. So this is the interesting version. So this model is associated with a run ID. I can go back to the run ID. The run ID is associated with an experiment, with a run, with a data set. I can do all of the lineage stuff. In fact, I can also do is to just download this model. So I trained it from the notebook. It is ready. So it should download. So once that is downloaded, I'll bring up, in fact, what it gives you. Let me bring this up. So again, there is no lock-in. So once you download a model, for instance, this is an example of a model that I downloaded from Automl. Automl, this will give you 3 things. One is the pickle file, the model binary itself. It'll even give you code to use the model. So if you look at the scoring file, this is how you can use the model on premises in your different cluster, different environment. Oh, it showed up in a different window. Give me a second. All right. So Azure ML auto-produced this scoring code, and this is how you generally call the model. Right. So you can, again, there is really no lock-in. You can use as much or as little as Azure ML. You can, in fact, even bring the models out. And then again, you can pick the experience of your choice. So write as much or as little of the code as you like. So I think that brings me to the end of the demos. Again, there are a bunch of resources. There is the GitHub page for all of the material that you saw, the notebooks, the data, and the tutorials that you can follow along. The only thing I think I changed in the tutorial is to be consistent with the same data set across the scenarios. And then, of course, there is the Azure ML documentation. Okay, I'll stop here. We have a few minutes for questions. And I can go a few minutes after too, if need be.
I think we have another talk coming up at 2. So,
okay.
So we'll.
All right. Okay. Then,
so
minutes.
Yeah, let's just see if there are any questions. Maybe one question if somebody wants to ask. But I think that was a pretty detailed look into the various flavors of Azure ML that people can use in various different ways. And I think this sort of, and since we are recording it, people can go back and look at this and take the time to understand and run their experiments.
Yeah, I think 2 things I would want to do before sign off is one, again, for any questions, you can just send me an email. Again, I'll put up the email. It's recorded. It's simple, sharat@sharat.org. I'll be able to answer your question. And the last plugin for people who didn't see this before I joined in, again, I'm in the Boston office of Microsoft, and we are hiring a bunch of, again, this is not my team specifically, but MADAP stands for Microsoft AI Development Acceleration Program. It's sort of a, we also call it the AI Rotation Program. It's targeted to new graduates. When you join, again, you rotate through different product teams. So our team will be one of those teams. You will rotate through Intune, Office, Docs, and you'll get different diverse AI experiences. So we are hiring across all positions, software engineer, data scientist, PMs. Okay.
So there's one last question about quick suggestions for upcoming data scientists.
Yes, I would say, I think, so it's very easy to get caught up in the details of the platforms and libraries that you use. So I think my suggestion would be learn about the abstractions that you can take across the different choices. So think if you can only work on TensorFlow, that's not a good thing. You should learn about PyTorch, about eager execution. So try as many tools as possible. I would say that's one advice. And two, I think at this day and age, the machine learning libraries and platforms are so mature that most of machine learning is software engineering. So you should be good at software engineering, especially in the industrial setting. It's very rare that you will invent a new model, but you really need to know how to apply it and integrate the model with other moving parts of the system. So I think, I would say, increase your range of experiences for tools and platforms. And two is you really need to get good at software engineering, because at this point, most of machine learning is software engineering.
Excellent advice, excellent tutorial. Thank you very much again, Sharat, for taking the time to
It's always a
do this.
pleasure. Yep. And email, always welcome. Thank you.
So the recording should show up on the website in about a week maximum. So once again, thank you all for attending the talk and attending this tutorial. Please, if you have registered for the other lectures at CDSE days, please attend and get the benefit of all of the nice speakers that we have.
Thank you all.
Thank you, Sharat. That was wonderful.
Bye-bye.
Thank you.